In this video we are going to describe the properties of a wave function. We will show the constraints on the wave function. For physical interpretation, a wave function must be well behaved. As already mentioned, each particle or system of one or more particles in quantum mechanics in the Schrödinger formalism is represented by a wave function, and the wave function containing all the information about the entire system. The wave function is a complex-valued function. From now on, we will consider the simple case of a single particle, without spin, in position space representation. In this representation the wave function is psi, r, and t. Wave functions can be added together and multiplied by complex numbers to form new wave functions, mathematically. C1, psi1, r, t, plus C2, psi2, r, t. Hence, wave functions are elements of a vector space. In this vector space, 1. A vector element is given by a complex-valued function. 2. The scalar product or inner product is given by integrals. Wave functions have a defined scalar product or inner product. Mathematically, in the position space representation of wave function we can write psi1, psi2 equals integration of psi1 dot psi1 over space. Hence, wave functions are elements of a Hilbert space. The scalar product or inner product of a wave function with itself is a positive real number. Mathematically, in the position space representation of wave function we can write psi equals integration of psi, r, and t, dot psi, r, and t, over space, more than or equal to 0. Where the equality holds only for psi equals 0. If wave functions have an inner product, then they have a norm. In order to show the constraints on the wave function, we are going to describe the properties of a wave function. Properties of a wave function are as follow. 1. Wave function must be defined and finite everywhere. 2. Wave function must be converged to 0 as r tends to infinity. Mathematically speaking, psi, r, and t tends to 0, when r tends to infinity. 3. Wave function must be single-valued. 4. Wave function must be continuous. 5. Wave function must be differentiable. 6. Wave function must be square integrable. All these properties are required for a well-behaved wave function.